All right, welcome back. So today we are going to do a question called number of 1 bits. So here's the question. Given an integer, find the number of 1 bits it has. Here's an example of some starter code. So let's go to the drawing board. So let's try to explain what this question is actually asking. So in case you're not familiar with bits, you should check out the course in Tech Interview Pro, number of bits. But here I'll just assume that you know the bits representation of numbers. So here we have an example. We have 23. If we go back to the code, 23 should output 4 because there's 4 number 1 bits, because 23 is represented by 1, 0, 1, 1, 1. And the reason why it's represented with this binary number is because 2 to the power of 0, you need 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 4. And that would be equal to 16 plus 4 plus 2 plus 1, which is equals to 23. So every single number, integer, can be represented by a binary number. And in here, you see that we need this number, the 2 to the 0, 2 to the 1, 2 to the 2, but we do not need 2 to the 3, and then we also need 2 to the 4. So yeah, so every combination is unique for every unique number. So this is our number for 23. Now the question asks, how many number of 1s are there? Right? So here, as you can see, it's 4. So usually just by looking at it, it's pretty easy. But how do we code this up? So the answer is actually pretty simple. What you need is an AND operator. AND operators like this. And then you also need a shift operator. And then what happens is, like, if the bits are both 1s, it becomes 1. If one of them is 0, then it becomes 0. So it's the same thing as the AND operator for most, for like logic stuff, right? So let me give you an example. Imagine I have a number 0, 1, 0, 1, 1. If I do an AND operation, the result will give me 1, 1, 0, 0, 0. And the reason why is because we have 1 zeros here. So, and then that would be the answer of the AND operator. And then shift operator, what that does is you just move to like either to the right or the left. For this one, you move to the right. So for example, if we do a shift operator on this number, what you're gonna get is 0, 1, 0, 1, 1, because you're actually just moving all of these guys to the right once. So this becomes that, this becomes this, and this becomes that. And then the 1, the last one, it just disappears, right? So it's actually the same thing as dividing the number by 2. So how do you answer this question? How can you know how many number of 1 bits there are? Well, so what we're gonna do is we're gonna do an AND operation with the number 1. And what 1 looks like is this, right? And then if you do an AND operator, you either get 1 or 0 here, right? So if you get 1, it means you do see a number bit 1. If you get a 0, it means this would be 0, right? This number would have been 0. So what you're gonna do, you're just gonna do that every time until you've exhausted the whole, like all the bits. And then you always keep a counter. Let's just say count equals 0. And then you keep a counter. Whenever you see a 1, you're just gonna add 1. So let's just do it right here. So let's do the AND operation. We get 1. So excellent, count becomes 1. And then what you wanna do is you wanna shift. You wanna shift. So now this number becomes 1, 0, 1, 1. And then you just do it again, on again, and again, and again. So essentially what you're doing is you're gonna check this guy. Is there a 1? Yes, it is. And then you're gonna check this guy. Is it a 1? Yes, it is. And then ever so forth, and then you get 4. Okay, so I'll do it like in a more understandable way. So once you shift, you get 1, 0, 1, 1. You AND operation with this guy, and then you get a 1 here. So you add a 1 to your count, so now it becomes 2. And then you shift again, now it becomes 1, 0, 0. And then you do the AND operation here, you get 1. So now the count becomes 3. And then you do the shift operation again, you get 0 and 1. That gives you 0, so you do not increment the count. And then you shift again, and then you get to the last person, at the last bit, you get 1, and then count becomes 4. So that's how you do it. All right, so let's think about the time complexity. What is the time complexity of this? So n represents the number, so it's 23. So how many operations do? We actually did log of n operation. And the reason why is because the number of bits that would represent 23 is only 5. And that's because that's the logarithmic of 23, right? In some ways, you're dividing by 2 each time. So every time you're dividing by 2 each time, it means how many times can you divide by 2 until it becomes 0? It's log of n time. So the time complexity is log of n. And then space complexity, we didn't add any space, so it's constant. All right, so that's pretty much it. So let's code it up. All right, so first what you want to do is you want to get the count, right? And then after that, you want to make sure, you want to keep doing the, the shift operator until the number becomes 0. So while the number is still bigger than 0, we keep shifting, right? We keep shifting like this, right? That's how you shift. This is the same as this. Oops. This is the same as num equals num shift by 1, okay? And then what we want to do is if we do the AND operation with the number 1, which is the same as like 0, 0, 0, 0, 1, and then if that is equal to 1, then we're going to increment our count. And then that's pretty much it. And then, yeah, so we're going to do that for every number. So when it's 0, we do not increment. And then at the end, you're just going to return the count. Okay, let's see if it works. Excellent, so we get 4. Excellent. Yep, so that's pretty much it. Yep, thanks for watching. See you in the next one.